This is the video for Unit 1, Lesson 6, Invertible Functions. The goal of this section is going to be to determine the inverse of a function algebraically and restrict the domain to make it what's called invertible. So if you remember from the previous video, we talked about when we were taking the square root of a function, and I think we had the function f of x equals the x plus 1 quantity squared. And when we actually ended up doing the inverse and we went ahead and solved, we had to do a square root, and in the video we talked about how you didn't need to put the plus or minus at that time. The reason is we actually want to create functions that are what's called invertible, right? So if I make an inverse, I want it to be that the function, when it has the inverse, that it is still a function, so it passes the vertical line test. So a function is invertible if the inverse is also a function, and if it's not a function, we're going to restrict the domain to make it invertible. So for example, if I had a quadratic, you can see that this would be a function. So if I did the vertical line test, it's a function. When we create the inverse of that function, you can see that it actually fails the vertical line test, right? So it's not a function. That means it intersects at 2 points, which means it's not a function. If we do want our inverse to be a function, we have to restrict the domain. So what we're going to do is if I'm looking at the function, I'm going to, instead of making the domain all real numbers, I'm going to restrict it from -2 to infinity. So I'm only going to take one part of that parabola, for example. And then when I do the inverse, it's still going to be a function. And that's kind of the goal of this video, is how do we restrict our domain so when I do have the inverse, it still creates a function. Usually this is going to happen when we're talking about parabolas or quadratics, because if I do an inverse, it's going to be something that's going to fail the vertical line test. So for example 1, we're given here just a graph. And so the graph, it says sketch the inverse using the restricted domain. So for this one, you can see our domain is all real numbers because it's just a quadratic. We're going to have to restrict that domain. And so the easiest way to do that is usually you're just going to identify the vertex if it's a quadratic. And we're only going to focus on one part of that parabola. So I'm going to focus maybe on just the right part. So you can see the x value is -3. So my domain is going to start at, instead of starting at -infinity, I'm actually going to start it at -3. And then it's still going off forever and ever. So I'm restricting that domain to be -3 to infinity. If I was to graph, if I was to go ahead and graph this, we would have it that you can make a series of points if we needed to. We can even reflect the points. So I have the point, for example, here, -3, 1. I have the point -2, 2. I have the point -1, 5. If I was to graph the inverse, I would just flip it around. So I would have 1, -3, 2, -2, 5, -1. So if I go ahead and plot that, it would look something, and I'm just going to graph that one piece. The you try, that's going to be for you to try out. We'll check that next time. But again, same process. You're going to restrict the domain and then flip a table and graph. For the last example, we're going to do the same thing. We're going to end up having to restrict the domain here. So we can see, for example, my domain, this is going to be a quadratic. So we have a 2. So it would be all real numbers. And we're going to go ahead and eventually write the inverse, but we have to first look at, well, if this is a quadratic, the vertex would be at 2, -9. So I take the opposite sign. And so I could see this would have opened up. So it would have looked something maybe like this down here. And so our new domain is actually going to start with the x value of the vertex. That's probably the easiest way to do it. And goes to infinity. So instead of using negative infinity, I'm going to use the 2. And now I can go ahead and do the same thing we did in the previous lesson. So I'm going to go ahead and flip this, rewrite this with a y. So I have x equals y minus 2 squared minus 9. Then I'm going to add 9. And then I would have y minus 2 quantity squared. And then now we're going to do the square root. I don't need to put a plus or minus because I restricted the domain. And I'm going to add 2 now. And so I would get y equals the square root of x plus 9 plus 2. Or I would write it as f of negative 1, or the inverse. And that would be it. If you have any questions, you can ask them in class, sign up for T-Bolt time, or get help in the center.